Anatomy and Physiology Tutorials, Basic Chemistry. Why study chemistry when learning about the human body? Well, guess what? You are made up of chemicals. Biochemistry is the study of the chemical aspects of life. Matter is anything that occupies space and has mass. In your body, chemicals are in the form of molecules, which are composed of smaller units known as atoms. Found in an atom are three subatomic particles. Protons carry a positive charge and are found housed in the nucleus of the atom. Neutrons, also found in the nucleus, carry no charge, so are therefore neutral. The electrons carry a negative charge and are arranged in energy levels, also known as shells, which orbit around the nucleus. The proton number, which is the atomic number, equals the number of electrons, so the atom itself is neutral because the number of positives equal the number of negatives, which cancel each other out. Atoms are neutral, but not always stable. A measure of stability is the total number of valence electrons. When an atom's valence, or its outer shell, is full, it is considered stable. If not, it is considered unstable. Take a look at this diagram of the distribution of electrons of some various chemical elements. If an atom's first energy level is its valence shell, it requires 2 electrons to be stable. If an atom's second energy level is its valence shell, it requires 8 electrons to be stable. And so on to the third energy level, which can hold more than 8 electrons, but is stable at that number. Consider hydrogen. It only has 1 electron in its valence shell, so this element is not stable. Helium, with 2 electrons in its valence shell, is stable. Taking a look at carbon, it has 2 electrons in the first energy shell and only 4 electrons in its valence shell, so carbon is an unstable atom. Looking at neon, having 2 electrons in the first shell and 8 electrons in its valence shell, is stable. The unstable atoms, such as hydrogen and carbon, will want to form chemical bonds with other unstable atoms in order to achieve stability. Therefore, it is the number of electrons in the valence shell that will determine the reactivity of the atom. An ionic bond is a type of bond formed between atoms in order to fill their valence shell. An ionic bond forms between 2 ions, which are atoms that have gained or lost electrons. So what are ions? Let's take a look at 2 neutrally charged but unstable atoms, sodium and chlorine. Sodium has 11 protons housed in the nucleus, 11 electrons filling energy levels, so positives equal negatives, 0 charge, neutral. Chlorine has 17 protons housed in the nucleus and 17 electrons filling energy levels, so positives equal negatives, 0 charge, neutral. Sodium's electrons fill energy levels with 2 in the first, 8 in the second, leaving its valence shell electron number as 1, not stable. Chlorine's electrons fill energy levels with 2 in the first, 8 in the second, leaving its valence shell electron number as 7, again not stable. So in order for these 2 atoms to achieve stability, sodium will donate its 1 lone valence shell electron to chlorine. Now sodium's valence shell is full at 8, as is chlorine's, having received the 1 electron it needed. We now say these atoms are ions. Sodium is a positively charged ion, a cation, because it still retains its 11 protons in the nucleus, but now only has 10 electrons. It has an extra positive charge. Chloride is a negatively charged ion, and anion, because it still retains its 17 protons in the nucleus, but now having received an extra electron, there is one more negative charge than positive. chloride is negatively charged? Well, we know what opposites do. They attract. The positively charged sodium forms what we call an ionic bond with a negatively charged chloride ion, thus forming the compound known as sodium chloride, table salt. Another type of chemical bond is a covalent bond. Consider these two hydrogen atoms, each which only have one electron in its valence shell. Both are unstable. To achieve stability, these hydrogen atoms both need two electrons in their valence shells. In order to do this, the two hydrogen atoms must team up. When we team up with another person upon taking on a position, we may call ourselves co-captains or co-chairmen. Well, that's what's happening here. Each hydrogen will share its one valence shell electron with the other, forming a covalent bond. Now stability is achieved because both hydrogen atoms now have two electrons in the valence shell. Covalent bonds form when atoms share valence shell electrons. Another type of bond, the hydrogen bond, is not like an ionic or a covalent bond formed by the donating and gaining or sharing of electrons. Slight electrical charges may develop in different regions of a molecule when tiny hydrogen atoms are not able to equally share their electrons in a covalent bond. Electrons spend less time orbiting the smaller hydrogen atom. This results in what we refer to as a polar molecule. Let's take a look at water, which is composed of two hydrogen atoms covalently bonded to one oxygen. There are two pairs of electrons, or two covalent bonds. Oxygen, having 8 protons in its nucleus, has a greater pulling power of those shared electrons over hydrogen, with having only 1 proton in its nucleus. Look at it like this. Oxygen is the bully pulling the electrons to its end, and hydrogen is the weakling. Since the unequally shared electrons orbit around oxygen more often, it gives this end of the water molecule a slightly negative charge, and the hydrogen ends a slightly positive charge. Water is a polar molecule, sort of like a magnet with its polar negative and positive ends. Now, what would happen if you put a bunch of magnets into a bag together? Would they not align themselves to the oppositely negative to positively charged ends? There is a magnetic attraction. Well, the same attraction of the negative oxygen end of water is attracted to the positively charged hydrogen ends. This very weak bond holding water molecules together is known as a hydrogen bond. Our last concept within the basic chemistry tutorial is pH. pH actually stands for potential hydrogen ions. pH is a measurement of the hydrogen ion concentration in a solution. A little background on the hydrogen ion. Take a look at a water molecule made up of 2 hydrogen atoms and 1 oxygen. Water does not always stay together. Sometimes it dissociates into hydrogen ions and hydroxide ions. Remember, ions are atoms that are now charged because they have lost or gained electrons. When water dissociates, all the shared electrons end up with the OH or hydroxide group. This is known as a hydroxide ion, leaving the lone hydrogen, known as the hydrogen ion, without any electrons. The hydrogen ion is positively charged. The hydroxide ion is negatively charged. Water is not the only molecule in which hydrogen and hydroxide ions are of concern. Acids are compounds that release hydrogen ions into solution, and bases take hydrogen ions out of solution. Take a look at the pH scale. The higher the hydrogen ion concentration of a solution, the lower the pH reading. as we will see with acids. Oppositely, the lower the hydrogen ion concentration, the higher the pH reading, as we see with bases. 0 is the strongest of acids, and as the reading moves towards 7, the solution becomes less and less acidic. At 7, the hydrogen ion concentration equals the hydroxide ion concentration, that being pure water. As the reading moves higher and higher, the hydrogen ion concentration is lower and lower, as we see with stronger and stronger bases. A low pH reading is an acid. A high pH reading is a base. The lower the reading, the stronger the acid. The higher the reading, the stronger the base. As you will see, stomach acid with a pH reading of 0.8 is a pretty strong acid. Household ammonia, having a pH reading of 11.9, is a pretty strong base. Let's review. High hydrogen ion concentrations will have a low pH reading. These are acids. Low hydrogen ion concentrations have a high pH reading. These are bases. When hydrogen ion concentration equals hydroxide ion concentration, the pH reading is at 7, neutral, neither an acid nor a base. This concludes the basic chemistry tutorial.